Hey folks, so this week we are getting into object-oriented programming. This is a major paradigm shift. If you're coming, through Python, where we did imperative programming, and then into the first 2 weeks of this course, where we basically did imperative programming in a main method, and that's been your full exposure to programming. This is going to be something quite different. So. The first page of this week's guide actually starts with kind of an explanation of what the difference is between the kind of programming that we've been engaged in previously, which we could call procedural programming, and object-oriented programming. And I think a good way to think of it is in terms of a game like Pong here. So the idea is that if you were going to program a game like this, we already kind of know what it takes to put an animation together, right? You can think of it as a sequence of things that you do one after the other. You draw the object, you pause, you clear the screen, you update the object position, you redraw the object, and then you loop back to the top. Some sequence. You think of it as a sequence of steps. In Pong, just to keep that going, but flesh it out into something that has user input. It's like an animation, but where the user can influence what's going on. So step one, clear the screen, update the ball, update the paddle if there was any user input, draw the screen, then you have to detect ball collisions, maybe change the direction, update the score, and then go back to step one. There should be a pause in there actually somewhere too, but there isn't. But you get the idea. Clear the screen, update everything using user input if necessary, draw the screen, pause, and go back to step one. So you think of it in terms of an algorithm, a sequence of steps to be performed one after the other. But in Java, now this doesn't go away in object-oriented programming. Fundamentally, this is the way computers operate, one instruction at a time. You have a single thread of control, or if you've got, you can have multiple cores, so you can have multiple threads. But generally speaking, we can think of most programs as being just a single thread of control working through a set of instructions one after another, occasionally jumping from here over to here or looping back on itself or whatever. But that's usually what we think of as a program. What object-oriented programming adds to that is the ability to actually kind of think about this Pong game in a completely different way. So when an object-oriented programmer looks at something like this, I want you to develop a new casual game, a Pong game, the object-oriented programmer thinks immediately about the structure of the program, not about the sequence of steps. And they think about what are the objects here, and how are these objects interacting with one another. So I use video games because it's easy to see what's going on. You look at that and you say, okay, I see a paddle. That's an object, and there's two of them. Two instances of the same kind of object. They're both paddles, but there's two of them on the screen. I see a ball. That's an object. What else do I see? Then it becomes a little bit more murky. Well, I see scores. Maybe that's a scoreboard at the top. Maybe that scoreboard is an object, and it keeps track. Its job is to keep track of the score. Maybe the field itself, the playing surface, is an object. And there are also objects potentially in play here. If you know what you're doing with programming, then you start to think about objects that you can't see, like who's listening for the keyboard input, who's listening for the mouse input. Well, there are objects for that. You can create objects for that purpose. They're called keyboard listener or mouse listener objects. So those are the things that are collecting the user input, and so on. So here's my example here, and yeah, there's a big caveat here. It's highly oversimplified, all of this, but so the purpose, the way that an object-oriented program works is you have multiple classes defining different kinds of objects, and then basically the way that the program works is you create a set of these objects, and then you kind of manage them. You let them interact, or you interact with them. And in some kinds of programs, like in a Pong game, often you can step back and actually exit the main program and let the objects interact with one another. So this is what the Pong example might look like from an object-oriented perspective. You create the ball object, you create paddle objects, scoreboard, keyboard listener. Oh yeah, I have a screen updater object here as well. That's another object that sits in the background doing work that you can't see. And then yeah, step 6 is relax and let the objects talk to each other. Okay, so some of these objects are autonomous. They're working on their own. in the code that we write, we're not going to have these autonomous objects that can operate on their own. We're still going to have a main method, but the bulk of the code, the bulk of the logic, is going to be in these objects. So, I mean, it's a very different way of thinking about object-oriented programming. It's a very different way of thinking about creating a computer program, creating an app. And it's a really important way of doing it. You get a lot of benefits from this. One benefit is, by breaking the code down, the problem down into smaller subproblems. Like instead of I need to code the whole game, you think of, well, I'm just going to code the paddle. Now I'm going to code the ball and the logic for the ball and so on. By splitting up code like that, you make it more maintainable. You allow multiple people to work at the same time. One person can be working on the screen updater while other people are working on the ball and the paddle objects and so on. And you make it easier to test because you can test one class at a time. You can test the ball on its own and then put it into the game. So you get a lot of benefits from thinking about code in this way. So what is an object? This is another way of thinking about it, is that, I mean, the idea here is that object-oriented thinking is supposed to be kind of deep in our psychology. In my experience, though, of many years of teaching this stuff, it's not so deep that people get it just like that. The idea is that the idea of creating code objects is supposed to kind of map how we think about the world. Like when we look around in the world, we see objects. I'm looking around here, I see a microphone, a screen. These are discrete things that have their own properties. The screen has a state, it's on or it's off. It has an image that it's displaying on it. It has a location in the world. These are properties of that object. And the object also has behaviors, things that it can do and that I can do to it. So I can turn it on or off. That's a behavior. I can move it from one location to another. I can, if it was a TV or something, I could change the channel on it, and so on. So objects, the idea is that we think about objects in this way, that they have attributes, which are their properties. So here's an example with a car. My car has a color. It has a type of transmission, manual or automatic, has a certain amount of gas in its tank. These are its attributes. And every car has these. And then it has behaviors. I can start the engine, I can turn off the engine, I can accelerate, I can brake, I can turn the steering wheel, and so on. So it has, we think about objects in that way, and we translate that to a programming language like Java. So a Java object is, what it is fundamentally is it's a package of instance variables, which we sometimes call fields. Those are the attributes. So if I was modeling my car, I would have a variable as part of this object for its color, another variable for the amount of gas in its tank, a variable for its transmission type, and so on. And I would have methods, which are functions, to implement the behaviors. So when I turn on my car, I would call a method, and it would change. There would probably be an instance variable for on or off, engine running or not running, and I would change that instance variable when I call the turn car on method, and so on. So here's I've got an example here. A string object contains a list of characters stored in some kind of instance variable, and then it has instance methods, functions, length equals index of. So this is relating it to an object type that we've seen before. To create objects, we have to create classes. So every Java class we write is, even if it has a main method, is a blueprint that can be used for creating a particular kind of object. Every Java class you create becomes a new type that you can use to define variables, to declare variables, and create objects of that type. Okay, so that's the basic idea. We're no longer going to think about things in a procedural way, as a list of tasks that need to be done. We're going to start trying to think about our code as a set of objects. And for each of those objects, we're going to think about what attributes do we need to represent. Those are our variables. And then what things can we do with these objects, or what things can these objects do? And those are our methods. And if you haven't thought about things this way before, it's going to take some time to get there. It's going to take some time for this to become a natural way of thinking. All right, so I want to start just by, let's create an example. So I have IntelliJ running over here. I've got the week 3 code already loaded into it here, but I think what I want to do is walk you through some new code here. So I'm going to create a new Java class, and I'm going to do the same example that's in the handout, we can work on some different examples. In the exercises, I'm going to have you design your own classes, which will be different examples. And in the live class, we can talk about different ones as well. So I'm going to create a circle class. So the purpose of this class will not have a main method. Notice its package name there matches this. So I'm not going to do PSVM tab here. I'm not going to create a main method here because I don't ever want to run this class on its own. What I want to do is use this class to create circle objects. So this might be useful in a drawing program or something like that, but it's just a very simple object type. Now at root, an object, what it really is fundamentally is it's a package of variables. So we're going to start there with what are called instance variables. Okay, I'll just write that here. Instance variables. Instance variables are declared inside the class body, but not inside any particular method. Okay, so hold on, let me just double check what I'm doing here. Yeah, so I might have a double variable for the radius. And I could say that by default the radius of my circle is 50. And I might have, I don't know, how about a color? Maybe an integer variable that represents the color. And we'll start with 0. Maybe 0 is black. Okay, and let's have an x and a y location. So double x, comma y, like that. So I've created, without using a method at all, and we're not actually going to use methods in this video, we're going to get to that in the next video, I have created a class which is just a package of variables. It's got 4 variables in it, a radius, a color, and an x and a y. And I have given default values to radius and color, but I haven't given any values to x and y. And that's all there is to a circle class. Now, I can now create in a separate class, I can create, let's call this circle main. So this other class over here, this is where I'm going to put my main method. Okay, so we're going to, for quite a while in the beginning of this object-oriented stuff, we're going to be doing 2 classes per app. There'll be a class that defines the object, and there'll be another class that has a main method in it. Eventually, we're going to have multiple classes for our app. So we're going to have multiple different object types, and then one class that contains the main method that's the runnable class. Now, this circle class, the fact that it's here inside the same package means that I can access it, and this has always been true. It doesn't matter what kind of class you've created. When you create a new class, you create a new variable type with the same name as that class. So if I go circle C, like that, I have created a variable of type circle. Okay, just like when I go string S. String is a built-in class, circle is a class that I made for myself. So I've created a reference variable here called circle that can hold a circle object. And if I want to, I can create a circle object to put there. And we do that using the new keyword here. It kind of looks like I'm calling the circle object as a method. And in fact, that is what I'm doing. I'm actually calling a special method called a constructor. We're not going to talk about constructors until next week. So for now, this is just, magic words. Just you have to put the brackets on there. And the word new, what it does is it creates a new object of that type. What I can do now is I can do this. I can do system out print line. Let's just print the circle object. But we can also print, for example, its radius like this. So over here in the circle object, I have a radius instance variable, and I can access it like this using the dot operator. This is called the dereferencing operator, and it's going to print out the radius. I can also assign to it like that, and then print again c.radius. I can also print x and y, even though I didn't give them a value, like this, plus c.y. So let's run this. Control-Shift-F10. Is it going to work? There we go. So the first line here, print out system out print line C, printed this weird thing. So what this is telling me is that this is an object variable of type circle, and the circle class is defined in the week 3 videos package. And the at is quite literal. It is at this memory address. So the rest of this is a memory address. So when you, what's going on here is when you say new circle, that sends off a request to the operating system. And the Java virtual machine says, I need some space in RAM for a circle object. How much space? Well, I need, 8 bytes for this double, and another 8, and another 8, so that's 24 bytes. And I have an int here, that's 4 bytes, so I need 28 bytes of memory, please. And the system goes off and finds a chunk of 28 bytes in a row of memory and returns the address or the number of that first byte. So this is a hexadecimal number that gives a location in RAM. Okay, so that's what's going on. Now, once again, these, just like with strings, this variable does not hold the circle. It holds the address of the circle. So when I use the dot operator, I'm saying go to this address and pull out the radius field from within, pull out the sequence of bytes that has been marked as the radius field for this object and print that out. So it's initially 50 because I initialized it to 50 here, but it's just like any other variable. If I can access it, which I can through C dot, I can change it, print it again, and you'll notice that even uninitialized variables have values. This is the one case now where we can actually access a variable. X and Y were not given values originally. Sometimes in certain contexts that gives you errors. In this context it doesn't. So they get initialized to their 0 value, which is 0 for a double. Okay, let's go take a look at the guide here. So here's an example of a class called Circle, and this is something called a UML class diagram. UML stands for Unified Modeling Language. It is a standard modeling language to depict the structure of an app and the relationships between classes in a way that's language independent. So whether you're developing in C# or PHP or Java or whatever language, if you're developing an object-oriented app, you can create a UML class diagram that is implementation independent, and then you can implement that diagram in Java or in Python or in PHP or C# or whatever language you want. This is a diagram for a single class. It has 3 boxes: circle. The top box gives the name of the class. The second box gives the instance variables, and the third box, which is empty here, is for instance methods, which we'll get to in the next video. Okay, so we're going to go back and forth between UML class diagrams, which is a visual representation of the code, and the actual code itself. Notice that the format here is a little different. Because this is language independent, we don't use the Java style of going double radius. We go radius : double, like that. So that the typical style is to put the variable name first. If you've got the textbook actually does it the other way around. It says double radius. It's not that big of a deal, but this is more standard. Put the name of the variable, and then its type, like that. Okay. Now I did want to show you, there's a second thing down here is this memory diagram. So let's take a look at some of the code here. Let's create a second circle, call it C2, like this, and then we'll do a system out print line of its radius. Okay, so circle 1 here, I don't know, let's also print it out. So if I run this now, you can see that what I've got is I got these 2 circles. The first one is at this memory location. The second one is at, is at the same memory location. That's not right because I put C here instead of C2. Let's run that again. Starting again here, the first circle is at this memory location. The other one is at a quite different memory location. So now I have 2 copies of each of these variables because I have 2 circle objects. I have 2 radiuses, 2 colors, 2 x's, and 2 y's. And here I'm showing you C2 radius, and up here I'm showing you C dot radius. So these are 2 different variables. Now what I want to do is just draw you a quick memory diagram of what's going on here. I think I can do this just by doing a full screen snip and then getting my trusty tablet here. All right. So I believe I can draw on this now. Yeah, I can. So I want to walk through this code one piece at a time. So right here, circle C, that creates a circle variable called C, like this. Now, what this contains when I first create it is the null memory address. This box is not going to contain a circle. It's going to contain the address in memory of a circle. And it's not until we do this part, new circle, that I actually get a block of memory out here. Somewhere out in RAM, there's a block of memory, and it has a radius, and it has a color, and an X and a Y. And the X and Y are both set to 0.0. The radius is set to 50.0, and the color is set to 0 by default. Okay, so these ones are I set, and these ones here were set. Where'd my other 0 go there? There it is, 0. Were set automatically because I didn't give them a value. The new operator goes in and gets that piece of memory from the operating system and then returns it to assign it to C. And so the number, this number down here, goes into this variable C. Usually I implement this in my diagrams. In memory diagrams, I show this as a pointer or a reference, kind of an arrow pointing to this piece of memory out here. Now I can do stuff. Let's go red here. I print out c.radius and I get 50. That's the first 50 I get there. Then when I do this, c gets me this. The dot says follow the arrow, follow the address. The radius accesses this part of this object, and I'm changing this now to 75. Oh, apparently that's, oh yeah, I got a smaller size there. That's okay. Changing that to 75. It's not the nicest looking thing. And then when I print it out now, I've got C75. And I can print out X and Y. The dot makes it go to here, and the X and the Y pick out those values from in there. I like this one better. It's more solid looking. But I want to create a different color here. Let's do a dark green. So then down here, C2, circle C2 creates a new reference. And new circle creates a brand new circle object in a different part of memory. Radius of 50, because it runs that code that's in the circle class over here. Color is 0. X and Y are both 0.0. And again, it returns the memory address, which gets stored in the C2 variable. And then when I print out C2.radius here, I am going C2 dot means follow the arrow, that means dereference, and then I get the radius value here, which prints out as 50. So you can see the two addresses here. This is the, this is the address of, I have a button for that. There we go. This is the address that's actually in here. Okay, so you can see that we literally have these, when I first create this circle class, and I create those 4 variables, radius, color, X, and Y, it doesn't actually cause those variables to exist. It's only when I do new circle that I get my first copy of those 4 variables. And then when I do new circle again, I get my second copy of those variables. Now, when you have, even if I were to change these so that these copies were the same, just like with strings, if you try to do this, if C equals C2, I want you to think for a moment, is this going to be true or false and why? So let's say that we did a C2.radius first equals 75. So then I have now changed this radius to 75. So the two objects have the same contents, but this will come out false. And the reason is because what we're comparing are the contents of these two variables, C and C2. We're comparing these numbers here, and they are not the same number. So this is false. So I have 2 different objects in memory. They can't be compared like this. If I wanted to compare these 2 things, I would have to go through and compare their radius, the color, the X and the Y, and so on. Another thing that we can do here, let's do this in yet another color if I can. How about brown? Yeah, brown. let's say I was to do this, C equals C2. So that's an assignment statement. So typically what it does is it takes the value on the right-hand side and assigns it to the variable on the left-hand side. Well, what is the value of C2? It's this number here. So what this does is this takes the memory address that's stored here and assigns it into the memory address that's stored here. You might think when you're doing this, if you're doing this with integers, it would kind of create a copy of integer C2 and put it into integer C. But that's not the case here. It's not creating a copy of the object. It's creating a copy just of the reference. So C now, after this operation, no longer points there. It now points there. So what we've done here is we have created what's called an alias. C and C2, two different variable names, hold the same object in memory. They both point to the same object. So now if we go, having done that, sorry, this is getting all over the place here, but if I go C dot x equals 5, and then do a system out print line, which I'll just abbreviate as sout, C2 dot x, that will print out 5, because C dot x right here changes to 5, like that. And now when I call C2 dot x, I get 5 there. Now, why am I going through all this in such excruciating detail? It's just really important to understand that when you create reference reference variables that refer to objects, they behave in a different way. They behave in a different way than regular variables. You can't just assign one to the other. You can't just compare them like this. The reason being that they contain references. They are reference variables. And that's what I'm going on about in this second section here. So if I create two objects like this, I have two different objects in memory. Here they are. And I set d.radius to 25. That sets this one. So this is going off of my example here, which sets radius x and y to 10, 100, 100. And then down here, I'm printing out c equals d. That will be false. Then I do this. D gets assigned to c. That breaks this connection and makes c now point to d. And if I change cx to 0, 0, it also changes dx. So when I print these two things, they'll be the same. And if I print out now c equals d, I'll get true. So let's try this up here. I'm doing it with c and c2. So I go c equals c2. Well, let's do the whole thing. System out print line c equals c2. And then I make them both the same. I go c dot color, no, radius equals 50. System out print line c dot radius, and system out print line c2 dot radius. And let's do a system out print line again of c equals c2. Okay, let me do this. C equals new circle, and c2 equals new circle. So this will have them, these two variables will now have brand new fresh circles, so they'll have the same contents. They'll have a radius of 50, and color and x and y will all be 0. And I will change the radius to 999, just so we can be sure that it's changed. 0.9, how about that? So when I run this now, what we should see, so starting here now in the output, C and C2 are not the same object, even though I just created them fresh, so they have the same contents. I set C equal to C2, and then I set C's radius to 999.9, and I'm setting the same radius of C and C2. And then I print out, are they the same? And now they are, because the two references are the same. Okay, so so assigning them, again, these variables contain references. And when you compare them, you're comparing the reference, and when you assign, you're assigning the reference. And it creates these weird situations where two variables or more can be aliases for the same object. They can be two names for the same object. This is going to be super important when we start passing things into methods and stuff like that. Okay, that's it. You might wonder, by the way, what happens to this object or this object here. So I cut the link. Now we have an object out here with no variable referencing it. We've lost it, basically. There's no way of getting it back. In some languages, doing that creates what's called a memory leak. C and C++, sorry, will allow you to create memory leaks like this. They're called memory leaks because if you do this over and over again, if you create an object and then get rid of the instance variable that was referring to the object, every time you do that, it takes up a certain number of bytes in memory. You're saying, give me some memory. And then you're not giving the memory back to the operating system. So after the program's been running for a while, the whole computer runs out of memory because it's asked for too much. That's why it's called a memory leak. It looks like your memory is leaking away. Java doesn't do that, though. Java does what's called automatic garbage collection. So the Java runtime machine, the Java virtual machine, keeps track of all the little bits of memory that have been requested, and it audits them as the program's running. And if it ever discovers that one of the bits of memory that was requested no longer has an instance variable attached to it, it will free it up, and it will tell the operating system that it no longer needs it and put that piece of memory back into the pool. Windows 95 years and years ago was notorious for having a memory leak. Windows 95 used to crash after a while, no matter what. If you could just leave your program running for a couple of weeks, and it would eventually crash because of this memory leak issue. Fun fact from computer science history. Okay, so what I would like you guys to do is, now I suggest in the README, I suggest that you work with a partner on this. And I think that that's a really good idea. Two heads are better than one, I've found, for this. So if you can, and if you're looking for a time to work together, we have our other class, the one that we don't use. It's either on Thursday or Friday morning, depending on which class we're in. If you can find someone who's willing to work with you, I think it would be very productive and very helpful for you guys to work together. You can do that using a technique called pair programming. It takes a little bit more when you're doing it online, but you can do it through screen sharing and by emailing code back and forth. So if you choose to work with a partner, which I think is a good idea, here's a model for doing it. This is a model called pair programming. It comes out of the Agile software development movement. It's used by a lot of software houses around the world. And what they found is that when a pair of people work together, the idea is that two people work on a single piece of code. So two people, one screen. When they're sitting together. When they're apart, obviously there have to be two screens. But two people, one piece of code. And what they found is, surprisingly, if the pair is working properly, if they're working well together using this scheme for two people working together, you can actually produce more code and better quality code than if the two programmers were working separately, believe it or not. So a lot of places use this technique. It comes out of industry. Here's how it works. You have a driver and a navigator. The driver sits at the keyboard and writes the code. So the driver's job is to write the code. The navigator's job is to think. The navigator watches the driver, thinks about what they're doing, watches out for errors, catches bugs and syntax errors as they happen, but also thinks about the overall plan. Where are we going with this code? Your job is to think a few steps ahead. Is what we're doing now going to help what's going on later? Is it going to cause problems for us? And the two of them work that way. And the roles switch frequently. So in industry, you might do every half hour or every hour, they might change places, literally change seats. The driver sits in the navigator's seat and the navigator sits in the driver's seat. In a class situation, I would usually say switch every 10 minutes, change roles. So I think you guys should give it a try. It's totally up to you. Obviously, I can't force you to do it, but I think it's a good idea. You can certainly also work on your own. So here's what I want you to do. I want you to pick one of the object descriptions below and draw a UML class diagram for the class that could be used to represent the object you chose. So a class diagram like this one here, right, with the class name here and the instance variables here. No methods yet. We'll add methods later, but just instance variables. And then implement it in Java code and write a main method in a different class that's going to create two different objects of that type and assign different values to the instance variables and print them out. Okay? So here are some options that I came up with, which I'll let you guys pick one. And what we're going to do is each of these methods, each of these exercises as we go, builds on. So if you choose bank account, you'll be using bank account for part 2, 3, and 4 of this week's material. So bank account, I'll just give you some ideas here. It's got a customer name, an account ID, a balance, an annual interest rate. Feel free to add more things to the bank account class if you think it's necessary or think it's useful. Square, this one's pretty easy considering we've done a circle. So if you're really feeling, worried about it, you could try this. But I would think you should try one of the novel ones. Here's a TV. So maybe we're modeling a TV, or maybe this is control software for inside of a TV. It can be on or off. It can be set to channels. I think this might be wrong. I don't watch a lot of TV anymore. I watch Netflix and downloaded content and streamed content now. TV channels don't seem to work the way they used to. I was looking at one the other day, and I was looking at channel 22.2. So you could feel free to model it that way, but here I've just got it the old way. It has 3 possible inputs: VGA, HDMI, and cable. The volume goes from 0 to 11. I don't know why 11. And so on. So think about things you can, things that a TV, what defines the state of a TV, current volume level, on or off, channel number, that kind of thing. Here's a different idea: a student. A student in this fictional course. A student has a name, a student ID, they have 5 grades, and so on and so on. So create an object that could represent a student. Finally, video game player. Maybe your Minecraft player has a user ID, an X, Y, and Z location, a color, maybe a health, number of hearts, etc. So if that one interests you, go for that one. Okay, so pick one of those. Work with a partner if you can, and if you're inclined to. Create a UML diagram, and you can just do that on paper. But if you want a tool for it, there's a couple of tools out there. I have them in the modules here. I have under resources. Here we are. 2 possibilities here. One is Draw.io, which works like this. You go here. There's another hoop you have to jump through first. You have to decide whether you want to store things on the device or on Google Drive or something. I'm going to create a new blank diagram. You have to give it a name. Put it on the desktop. Test diagram. And we don't want this. We want UML. And right here, this is your class diagram here. And you can double click this and change stuff, put the name here and so on. So that's one way to create a class diagram. Can we zoom in? Yeah, we can. That's one way to do it. There's also another little tool that I don't know if you guys will like it, but I really like it. Let me run it here for you. It'll take a second to run. Go back into the resources. It's called Umlet. It's actually written in Java. If you click on this here, this is a pretty not very nice looking page. But if you click on download here, you can get the standalone. And it's also available as an Eclipse plugin. I've never tried it. The standalone is just a zip file. Just unzip it, put it somewhere, and then run the executable. And you get this. I'm going to zoom in a bit here. And it's a bit weird the way that it works, but it's kind of a hacky interface, but I like it. So I want a class diagram, so I pull this over here, and I configure it over here. Now this is pretty small, but so I want, oops. Let me do, the class diagrams that are in the notes are all made using this. So I can do circle, radius, double, x, I don't know, int, y, int. And I don't need this here. So you can see the way it works here just by example. The dash dash creates a line that you can then add things to. So I just put 2 lines there and I've got this box. I don't need anything down here. So yeah, it just looks like that. Anyways, that's the one that I use, and you can export these things as PDFs, as JPEGs, and so on. I export them as JPEGs and put them in the document. Similarly with Draw.io, you can export as a PDF like that. Let's crop it and export. Sure. Download. And it'll probably auto open. Whoa, look at that. There you go. So there's my class diagram from Draw.io. Okay, so you can use one of those 2 tools for creating your class diagram. And then once that's done, you're going to put it into code. So do the design first and then translate it to code. It'll look just like this, but with a different name here and different variables. Feel free to do some default variable values here. And then you're going to create a main method that's going to create 2 copies of the objects. Just get your feet wet, practice assigning to the variable names that you've created and printing them out. Okay, that's it. This video was a little longer because I introduced pair programming and another tool and so on. Next video, we're going to look at instance variables. So I will see you in that video.